Hello, geometry students. I want to kind of wrap up our reflection section, make sure we understand a couple of the key pieces that are happening. So the very first thing we need to understand about reflections is that the notation is probably the most important part. How we write that a reflection is happening, the directions that it's telling us, the orientation, all of these things are really, really important. And so here's the general formula. And if you don't have this written down, I would make sure you have it written down somewhere. But we have lowercase r, which represents the reflection, over a very specific line, the x-axis, y equals 5, line L, a lot of different things we could have here. But this is telling us where to do the reflection of the pre-image, right? So this is kind of like the original image equals this new image, or what we call the image. Okay, so we've got a reflection over a very specific line of the original shape equals the new shape. And it has to have all of those components in order for it to be a reflection. And these are telling us what to do, and in a sense, how to perform the reflection either on paper or on a coordinate graph, anything like that. So pay close attention to what's happening here. So let's just take a look at an example. This example is telling us, again, the lowercase r is to do a reflection. So I'm just going to write reflection, or I'll abbreviate reflect. This is our line over the x-axis. They want us to take this pre-image, which is on the graph to the right, GLQ, and create an image called ABC. So we need to basically take this pre-image GLQ and reflect it across the x-axis and name the new points ABC. You'll notice that GLQ is going to match up with ABC. So G has to match up with A, L with B, and Q with C. So let's see what that might look like. Let's start with G. If here's G, and I got to go over the x-axis, here's the x. This G has to come opposite side of the x. So I'm going to count how many units it is away. 1, 2, 3, 4. So I'm going to go 4 on the opposite side. 1, 2, 3, 4. There is my new point G, which they're telling me to label as A. Point A. Then I'm going to do L. L is 1, 2 away from the x-axis, so it's got to go 2 to the other side. This one should be B. And then Q is 1 away. It's got to be a mirror image on the opposite side. So this one's actually going to go up and be labeled point C. If I connect them all, there's that line, here's that line, and here's that one. There is the reflection of GLQ, which created ABC. Okay. Now, if we think about, this is the bigger one that we often talk about, the orientation. Right? Which way are we traveling around the shape? Orientation. Which way are we going? G to L to Q. And I'm going to grab a different color just so I can show it. G to L to Q. Right? So that's this arrow. G to L to Q. This orientation is counterclockwise. It's going opposite of what a clock normally goes. So just to help us abbreviate, I'm going to write counter. Whereas the orientation of A to B to C, so A to B, then all the way up here to C, this has an orientation that is clockwise. So notice they're opposite or they are different. And that's part of a reflection in that we are going in opposite directions. Okay, so again, our reflection line of the pre-image, flipping everything over the x-axis to get this new shape A, B, C. Now, occasionally they'll also have us do it with certain points, right? They want us to take these 4 points and reflect them across y equals -2. All right, so I'm going to draw this line first, y equals -2, which is this line right here. Right down here, y equals -2. That's that line, y equals -2. So everything needs to get flipped over that line in a sense. I need to take the point -1, -5, so that's h. The point -1, -4, that's m. 1, -2, which is point B. And 3, -3, which is point C. We need to reflect all of those over the y equals -2 line. So if I start with h, which was down here, 1, 2, 3 units away, I'm going to go 1, 2, 3 units, and I get this point. We'll just name this one h prime, showing that it's the new h point. M is 2 units away, 1, 2, so I'm going to go 1, 2 units this way, create that new point M prime. B is right on the axis, or it's right on, not the axis, but it's right on that line. So its reflection is actually going to just stay right on that line, and we'll just show that by saying B prime up above. And point C is 1 unit away, so I'm going to draw it right here and call it C prime. So we can reflect individual points as well across different lines as we need to. Okay, so that's really how the reflection piece is kind of working. Those are some of the things that we're going to be asking you to do on our test. The other part is, how do I draw or find the reflection line so that I can also write a rule? So this left-hand example is asking us to write a rule to show the transformation. What changed? And you can see here I've got x gf and x prime g prime f prime. So this is our image, and this was our pre. How do I know that? Well, it's this prime, this apostrophe. So we have a reflection, lowercase r, of some line of the shape x, f, g equals, in this case, they match up, x prime, f prime, g prime. What we have to figure out, though, is what line. I don't have a line in here yet. In order for this to be an accurate notation, I need to figure out what line. So to figure out the line, I'm going to draw in here from G prime to G. Notice that's 1, 2, 3, 4 units. They're 4 units apart. That means I need 2 units on each side. So 2 units there and 2 units there, meaning this line right here is my reflection. Well, what axis is that? We could say the reflection over the y-axis. Reflect the pre-image over the y-axis. Others might also put the line x equals 0, because that's the actual equation for that line. Okay, so we might have to sometimes write these rules for the notation. The last example on the right, though, actually wants us to draw in the line. Like, how do I know where to put that line and what's going to be happening? So if we kind of look back to what we did here, I connected 2 points. That's my first step. I'm going to connect D to D prime, knowing that that's the distance between them. Okay, that's the physical distance. What we have to figure out is, how long is that line, right? I need to know where the midpoint is. And because, unfortunately, we don't have rulers inside of Desmos or inside some of these like Google Forms when we're taking tests, what we're going to do is we're going to estimate as closely as we can, and we have to include 2 things. So I'm going to just say that that looks about the middle. How do I know it's the middle? What evidence do I need to include? I need to show that this segment right to that point and this point to that dot, that those 2 segments are congruent. We need to be able to show that they are congruent. Then the second part about the line of reflection is that the line between D and D prime has to be a bisector perpendicular with our line of reflection. So I need to also make sure that I draw in that right angle. All right, so there's two key pieces to showing that it is a reflection line. One, I got to have a right angle to show the lines intersect perpendicularly. And two, I got to show these congruent marks to show that the distance to the reflection line is the same. So that's a little bit of a review, a little bit of a recap here for reflections and what you should be able to know how to do. As always, it's really important that you make sure you reach out and ask your questions if you have them. Otherwise, we'll catch you next time. Stay safe.